Hello everyone, I'm Francisco Chris Arulanantham. In this assignment, there are three main questions. Now, we will discuss the first question. The first question is, the regular motion of the Earth about the Sun causes the daily change in the high temperature at any location on Earth. The chart and graph show the average daily high temperature in degrees Celsius for each month in Yellowknife NWT, compiled for several years. Determine the trigonometric equation that models this information. Let y be the temperature in degrees Celsius and x be the numerical value of the month. The data given in the table shows that temperature increases every month, then decreases after July. You can see in this table. We have to determine the trigonometric equation that models this information. The graph of a trigonometric function is given here, where temperature is in y-axis and months in x-axis. Now let us move on to the procedure to find the model for this information. First, observing the data and the graph given. The table given indicates the data of the average daily high temperature in Celsius for each month in NWT. The model indicates the cosine function that is reflected in x-axis. We can observe the maximum and minimum values given there. It is trigonometric model, whether sine function or cos function. Now we consider the following cosine graph. Given graph is reflection of this cosine graph. This is the reflection given below. It is identical to the given graph. In briefly, the similar format given in the question is obtained by reflecting the cosine graph that I have drawn the first. It is clear that cos graph reflected vertically over x-axis. Now assume that our function is fx is equal to minus a cos b into x minus d plus c, where a is amplitude, b is 2 pi over period, d is horizontal shift, and c is vertical shift, where it is clear that a is positive, therefore minus a is negative. Next, we will calculate each parameters. First, amplitude is equal to maximum value minus minimum value over 2. To find amplitude, we have to observe the maximum value and minimum value given there in the question. The maximum value is 21 and the minimum value is minus 24. So amplitude is equal to 21 minus 24 over 2. We can get amplitude as 22.5 degrees Celsius. Now let's calculate the value of C, which is vertical translation of the function. C is equal to maximum plus minimum over 2. If we substitute the value, the maximum value is 21 and the minimum value is minus 24, we will get C as minus 1.5 as vertical shift. Now let's calculate the value of B, where T is equal to 2 pi over mod B. T is the time taken to one revolution, that is in the graph. T is the interval between the maximum or minimum. But in the given data, only minimum is given. That is January to December, 12 months. So the period B is equal to 2 pi over T is equal to 360 over 12 is equal to 30 degree is equal to plus pi over 6. Next, we will find phase shift D. D represents in the trigonometric function for the phase shift horizontally. Here, how many months are shifted along x-axis? This is what we have to find in the given graph. In this context, there is no phase shift. So D is equal to 0 as no horizontal shift. Now we can write the equation of the function. We assumed the function is fx is equal to minus a cos b into x minus d plus d. We have calculated a, b, d and c. So if we substitute, the function is fx is equal to minus 22.5 cos pi over 6x minus 1.5. This is the model which represents the temperature for each month in NWT, where y equal fx represents the temperature in degrees Celsius. And x is the numerical value of the months. Y equals minus a cos b into x minus d plus c, where a is 22.5, b is pi over 6, it means 30 degree Celsius, c is minus 1.5, d is 0. So the function is y equals minus 22.5 cos 30 degree x minus 1.5. Now we have completed the question number 1 in mid-unit assignment. We will move on to question number 2. A Ferris wheel has a diameter of 10 meters and takes 24 seconds to make one revolution. The lowest point on the wheel is 1 meter above the ground. A parties sketch a graph to show a rider's height above the ground with time as the Ferris wheel makes a rotation. Assume the person starts the ride at the lowest point on the wheel. B parties write a trigonometric equation that describes the graph, and the C parties check the accuracy of your equation by using t equal 12 seconds. Explain why this provides a check of the accuracy of the equation. What are two more values that would provide a good check? Now we will discuss the A part in question number 2. Sketching a graph for height of rider from ground versus time. First, We represent the data in a diagram of Ferris wheel to draw the graph. Height versus time function, which may be trigonometric of sine or cos curve. According to data, minimum height of a rider is 1 meter and maximum of 11 meter above the ground level. Diagram for the given data, Ferris wheel rotation. Minimum height of the rider 1 meter at t is equal to 0 second above the ground. Maximum 11 meter at 24 seconds from the ground level. Period is equal to 24 seconds. You can see the data are shown in this table. This is the diagram for the given data. You can see here. According to the table, 5 key points are here. Using these key points, we can draw the following graph. You can see in this graph, this is h is equal to 6, midline. In y-axis, height in meter, and in x-axis, time in seconds. Now we will move on to B part in this question. Write the trigonometric equation that describes the graph. Identification, the trigonometric function. As the rider moves up from the rest at the lowest point and motion is circular, we can illustrate the function is cosine. We can observe that from my previous graph, of which reflection over h is equal to 6 axis is cosine graph. We confirm that vertical reflection of the previous graph becomes cos graph over the axis of y equals 6. It means h equals 6. Next, evaluation of parameters. Let ht is equal to minus a cos k into t minus d plus c. Evaluating amplitude A. As I drawn above, the maximum and minimum values are 11 meter and 1 meter respectively. So the amplitude is equal to maximum value minus minimum value over 2. So if we substitute the values, we will get amplitude as 5. Next, evaluation of value k. As the time taken to one cycle is 24 seconds given in data, the period t is equal to 24 seconds, but k is equal to 2 pi over period is equal to 2 pi over 24 is equal to pi over 12. It means 15 degree. Next, evaluation of phase shift d. Here we notice that the graph that I already drawn was started at t is equal to 0. Therefore, vertical axis does not change. That is, y-axis is the vertical axis in this context. And graph starts with minimum 1 meter at t is equal to 0 according to the previous graph. But in this context, reflection graph over y equals 6 axis starts with maximum value at t is equal 0. Therefore, there is no phase shift. So d is equal to 0. Next, evaluation of value of c. As I already said, maximum value is 11 meter, minimum value is 1 meter. So C is equal to maximum value plus minimum value over 2. If we substitute the values, we will get C as 6. Y equals 6 is the middle line of the graph. Finally, we write the equation of function. If we substitute the values for A, K, D and C in the equation, ht is equal to y is equal to minus A cos k into t minus d plus c. Amplitude is equal to 5, value k is equal to pi over 12, it means 15 degrees, phase shift d is equal to 0, and the horizontal middle line C is equal to 6. By substituting, we will get the function as ht is equal to minus 5 cos pi by 12t plus 6. This equation describes the motion of a rider at height ht against time, where h be the height from the ground. Now we will move on to the last part of the second question. C part is, check the accuracy of your equation by using t is equal 12 seconds. Explain why this provides a check of the accuracy of the equation. What are two more values that would provide a good check? So, observe the diagram of Ferris wheel at 12 seconds. The rider is at the maximum point on the wheel at h is equal to 11 meters above the ground. Observe the graph that I drawn where at t is equal 12 seconds, graph reaches the highest point. So in that graph, we can see 12,11 point. Next, checking at t is equal to 12 seconds. ht is equal to minus 5 cos pi over 12t plus 6. If we substitute t as 12, h12 is equal to minus 5 cos pi plus 6. So we will get h12 is equal to 11 meter. It is true in the data given and check in the graph also, the rider is at 11 meter height at t is equal 12 seconds, as the period is 12 seconds and this is half revolution. Two more values to check the equation. This is the next step. T is equal to 0 and t is equal to 24 seconds are most suitable, as obviously 0, 1, 24, 1 are given points in the data, so t is equal to 0 and 24 seconds are suitable. Now we will discuss question number 3 in this assignment. The height of the tide in the Bay of Fundy relative to a pier varies from a low of 4.5 meter at 2:08 to a height of 7.3 meter at 8:21 measured with a 24-hour clock. A parties assume that the height of a tide can be modeled as a cosine function of the time of the day t, and then determine the equation in the form ht is equal to a cos k into t minus d plus c. B parties where ht is the height of the tide at the pier in meters and t is the time of the day in hours. C part is determine the height of the tide relative to the pier at 11:30. Give your answer to the nearest 0.1 meter. D part is a boat needs a depth of at least 12 meter to dock at the pier. Use a graphical approach to determine when the boat is able to dock and when it must leave. So now we will discuss the answer for A part in question number 3. First, data conversion of the time of day. The time 2008 can be converted into 24-hour clock in hour as 2008 equivalent to 2 hours plus 8 minutes. So it's equal to 2.13 hours. And 8021 equivalent to 8 hours plus 21 minutes is equal to 8.35 hours. Therefore, the lowest time given is 2.13 hours. Highest time given is 8.35 hours. Next, plotting. Let's graph the HT against the time. You can see in this table, these are the key points. We can make an idea to determine the values of K, A, D and C using the following graph. By plotting height versus time, we can easily determine the values of A, K, D and C. Maximum value is 17.3, minimum value is 4.5, half period is equal to T by 2, T by 2 is equal to 8.35 minus 2.13, so we will get T as 12.44 hours. According to the data given, we can sketch the curve. You can see here the curve. The highest point is 17.3 and the lowest point is 4.5. Here note that period T is equal to 12.44 hours and the curve is cosine function at the starting time of 8.35 hours to the maximum of 17 meter. Also, according to the shape of the graph, there is a pace shift of 8.35 hours as maximum starts at 8.35 hours. Next, amplitude A. Amplitude is equal to maximum value minus minimum value over 2. The maximum value is 17.3 and the minimum value is 4.5. So if we substitute, we will get amplitude as 6.4. Next, evaluating the value of K. According to data, the minimum occurs at 2.13 hours and maximum becomes at 8.35 hours. This gap is half period. Period is equal to 8.35 minus 2.13 into 2. So period is equal to 12.44 hours. Therefore, K is equal to 2 pi over 12.44 is equal to 0.5053 radian. So the K is equal to 0.165 or 28.93 degree. Next, evaluating the value of C. C is equal to maximum plus minimum over 2. Maximum value is 17.3. Minimum value is 4.5. If we substitute the values, we will get C as 10.9. Y is equal to H is equal to 10.9 is the middle line of the graph. Next, evaluating value of D, phase shift. In the above graph, cos function has to start with a maximum of 17.3 meter. So it begins with 8.35 hours. There is a phase shift of 8.35 minus 0 hours. So D is equal to 8.35 hours. This is right shift. Substituting the parameters in the cosine function is the next step. We assume the function is ht is equal to a cos k into t minus d plus c. Amplitude is 6.4, k is 0.16 pi or 28.93 degree. Phase shift D is equal to 8.35 hours. Horizontal line midline. C is equal to 10.9. The modeled as a cosine function is ht is equal to 6.4 cos 28.93 into t minus 8.35 plus 10.9. The answer for the B part also included in the above part. So we will move on to C part in question number 3. Determine the height at 11.30. Give your answer to the nearest 0.1 meter. 11.30 is equivalent to 11.5 hours. ht is equal to 6.4 cos 28.93 into t minus 8.35 plus 10.9. H 11.5 is equal to 6.4 cos into 28.93 into 11.5 minus 8.35 plus 10.9. So H 11.5 is equal to 10.77. Therefore, it is 10.8 meters height of the tide. In this case, this 11.30 is equivalent to 11.5 hours is 24 hours clock time converted into hours. Now we will move on to part D. A board needs a depth of at least 12 meters to dock at the pier. Use a graphical approach to determine when the boat is able to dock and when it must leave. Here we can find the time gap on which the tide would be at a height of minimum 12 meters using the graph above. Let us see the graph below. There are a couple of time on which the height of tide is 12 meters. Assume that the times are T1 and T2. By drawing a parallel line, h is equal to 12 meters to the x-axis, we will get 2 points where the line cuts the curve in these 2 points as shown in the figure. It means these are the 2 times. T1 is equal to 5.59 hours. T2, this cutting point, is equal to 11.11 hours. Therefore, the times on which the boat can dock at the pier at the time of 6.00 and 11 hours and 7 minutes in 24 hours clock. Thank you.